Hello everyone. Today we are going to talk about the cross product, but the cross product to get the moment, the moment that produces a force applied to a distance, and we will go on with the main example that we started at the beginning. So I would like to check about some data. This is the first problem that we have been studying along these lectures. If you remember, we transformed this force in the two components of the main axis. So in general, we are going to use this axis. This is the x-axis and this is the axis y. And the origin is going to be placed in the main base of the teeth. Here, this force, as you remember, was decomposed in both components. Here is minus 13.9 y newtons, and this component here is minus 13.9 J newtons. So the force, this force, is equal to minus 13.9 y, minus 13.9 J. This is this is the force. Okay? So, considering that, additionally, the distance, this is the vector distance, we are going to use vectors as well. This is the vector distance between the main base or the axis of the teeth and the application point. This is the vector. And if we read this information, we can see that the force application point is 4 millimeters from the axis of the tooth and 9 millimeters high. So it is that this vector is 4 millimeters in positive direction y plus 9 millimeters j. If we want to use units of the international system, this is going to be 0.004 y plus 0.009 j. So this is the distance vector and this is the force. So if we want to know the moment produced, let's transform it in a model. This is the main base and this is the model of the teeth. Here we are the force, and this, I'm going to use another color. This is the distance vector, and this is the force. Now, if we want to know the moment produced here, the moment is going to be the cross product between distance vector by force vector. So, you remember what I explained in the slides. We have to put y, j, k. This is happened because the moment is another vector who is going to be placed in the z-axis in 3D. But for us, don't care, don't panic, because all the moments are going to be placed on the K. So for us, no axis. This is simple. That it's only to be more accurate. So the distance vector is going to be 0.004, 0.009, 0 in the K, and force is going to be minus 13.9, minus 13.9, 0. Okay? This is what we have to do. If you remember, we are going to add once again these lines y, j, k, and 0.004, 0.009, 0. Okay. As a result, we are going to do the cross product like this. This here we are at 0, so it means that 0, minus 13.9 multiplied by 13, so this is minus 13.9 by 0.04 K, and we have to remove minus this line, because this is 0 and this is 0. Okay, so which is minus 13.9 by 0.009. Okay, so in general, if we make these operations, as a result, we get that the moment, or the absolute value of the moment, is going to be 0.0695 newtons meter, which are the units of the international system. So here we are, the results that we have obtained by calculation handmade. But we can use as well the tools that I explained. So if we check the in the slides, here we have the slides, and here you are some tools. If we use those tools, for instance, that one, here you are that if you put the numbers here, this is the online calculation for cross product of two vectors. If we put the distance vectors and the force vectors, and we try to obtain the result, this is the cross product. It's exactly the same. And if we prefer to use the other tool, which is that one, is the same. We can put here the distance vector, and if we say go, the main calculation as a result is exactly the same. So I would like to show you one important thing, which is what happens if we shift the two vectors. If we put here minus 13.9, minus 13.9, here is 0.004, and here 0.009. If we go on, the solution has the opposite sign. So be careful with that, be careful with that. So, well, I hope that this video helps you, and if you need something, please do not hesitate